All right, so we are two past and we've already got almost 200 attendees, so that's fantastic. So as we mentioned in the invite, we're trying something a little bit different today. So with every release, we like to do a webinar to kind of cover what's new and hot, but we wanted to make it different and make it much more interactive. So we're calling this office hours. And so today is really an opportunity to have more of a attendee-led, question-driven session. And we've got an awesome field of experts here that you can ask questions for. So let's go ahead and meet the team. And again, jump right in, right? We absolutely want this to be, about what you want to learn from. Let's go ahead and do some introductions. Andy, tell us a little bit about yourself and actually tell us where you're presenting from today, because it looks like an awesome background there.
Yeah, today I'm presenting from Antigua. It's a nice, warm, sunny day here, as you might imagine. My name is Andy Pernsteiner, Field CTO at Vast. Been here about 5.5 years. Prior to Vast, I worked at several stints at storage and analytics startups, including MapR and Isilon and a few others. And today we're going to talk about a lot of our features that I'm excited to talk to you about.
That's awesome. I'm trying to look at your glasses to see if that's actually a real background or one of those fake ones, but I'll believe you.
I move out of the way, you can see what there is.
Yeah, it's for real. Rupert, you're also a world traveler today. Where are you at? And tell us about what you cover here. Oh, audio, Rupert.
Yep, got it. Hi, everyone. Rupert Menezes, Field CTO here at Vast Data for AI and emerging technologies. I'm out of the sunny state of Toronto, Canada. I'm in a hotel, so my background, I don't have the great background that Andy does. Prior to being here at Vast, I was at several large storage companies, Dell, EMC, and doing the same sort of Field CTO gig, focus on AI and emerging technologies.
Awesome. Well, glad we have you on, and your internet seems to be working just fine. So, Phil, you and I are the only homebodies today. So, tell us what you cover here.
That's about it. Yeah, my name is Phil Wakestrom. I'm based out of Minneapolis, so I'm actually not traveling this week, which is a good change. My background, been with Vast here now for about a year. My background came from DDN and Nexenta Systems. Prior to that, I was with Sun Microsystems and Oracle with that. So happy to be here and happy to answer any questions. Mostly focus on multi-protocol and multi-tenancy. So
excellent. And I should have introduced myself. I'm Steve Perchewski. I'm on the product marketing team. I'm based in Raleigh, North Carolina. Yeah, we'll go ahead to the agenda slide. And again, we're showing you this agenda, but really we just want it to kind of help us guide through. So take a look at these topics. Think of your questions. We're going to start off with just an overview of how we do our releases, what's going to be in that 4.6 release, which is GA as of last month. Andy's going to dive into a new feature we call Vast Catalog. Then Phil will be talking about our new multi-tenancy features. Rupert's going to cover our quality of service, QoS policies. We'll touch briefly on global snapshot clones, and then we'll give you a preview of what's coming in the 4.7 release. So again, jump in with those questions, and we're more than happy to talk about them. So just a quick kind of review of how we do our releases. We always pair a major and a minor release. The major release for this cycle is Vast 4.6. It came out last month. We've got a series of blogs on what's in the release and even some links to some demos. So again, if there's something that we cover today and you want a deeper dive, we can certainly talk with you, and you've got a little ability to go look at some other blogs. You'll notice there's kind of a theme here. So we're really working with a lot of service providers. We've got service providers who are both taking Vast and offering our file and object services directly to their customers, but a lot of other service providers who are taking us and then building their own, SaaS offerings on top. So we want to take all the scale and performance of Vast and be able to portion it up into easily consumed things. And something that service providers really like about Vast is the operational efficiencies that increase. So we talk a lot about reducing the cost of flash to that of disk, but the other thing is if you can manage, systems that are in excess of hundreds of petabytes with, less than a quarter of a full-time employee, it's just really, really efficient. So some of the major features today, the Vast Catalog that Andy's going to touch on. Essentially here in this box here, the major things, don't spend too much time because we're going to demo. We're also rolling out new features that are enhancing our data protection service. So things like fast local snapshot. We're increasing the features for all of our protocols. So we're continuing to add more features to S3. We're seeing a lot of adoption around object storage. We're also adding more things for increased authentication providers. And under our UX feature here, we've got a really cool feature called Uplink with machine learning capacity predictions. So this is our fleet management service, and we're actually using machine learning to look at the way you both consume and delete storage over time, and then give you a prediction of what you are going to use. So some really interesting things that are going to happen there soon. Let's go on to the next slide. So one of the things you'll notice and people have commented on is Vast is very quickly rolling out a lot of features, especially in comparison to our competitors. And a lot of that is because of our architecture. It's a brand new architecture built for NVMe. So we don't have a lot of that legacy things that are holding us back. We don't have to build or compensate for things like hard drives. And one thing you'll notice as we go through our features is a lot of these features are deeply built on some things that were already built into the architecture. So with another vendor, you might have to do like a bolt-on. And really a good example of this is what we're going to show next with our element store. So let's go to that next slide. So again, Vast was built to be a data platform. So rather than a NAS platform or an object platform that we then cobble services on top, we store data as elements, and then we present them to you over the protocol or API that you need. And if you've seen this slide before, you'll notice there's some new elements in here, and the Vast data catalog is one of them. So Andy, let's go ahead and jump into what we're introducing here, calling the Vast catalog.
Great. Let me share some slides of my own. Let's start.
Excellent.
Okay. So just a real recap, I guess, on the element store in general. It's effectively what most people would deem a file system. However, because we've extended it with a lot more functionality besides just files, we called it an element store. And the main thing to consider here is that the element store is the underlying structure, how our data is stored. And all of the protocols or interfaces into it are layered on top. Now, the way that we've done this, and we go through this in a lot of detail later, is that we've built all of our own protocol stacks in-house. We haven't taken any open source projects. We haven't layered it on top of separate file systems. They're all standing as equal peers, as it were. And so data that's written over one protocol is accessible over another. And today I want to talk to you about when data lands on the system, how it can be cataloged automatically so that you can enable more easily definable administrative reports to be able to find data where you're looking for it, that sort of thing. So I'll just kind of drop you through a couple things really quickly. Basically, the Vast catalog is recently introduced in our 4.6 release, which is currently shipping in GA. And effectively what it allows for the system to do is whenever new data is ingested, updated, or deleted on the system, this could be over a file interface like NFS, SMB, or it could be over an object interface like S3. Whenever that data comes in, it is then automatically cataloged in an internal database table that we've created on our platform. We actually are developing our own internal database format as well. And this is the first use case that we're using it for. Now, you can get simple things that you might expect from a catalog, such as the name of the files, the path that they're in, timestamp information, the information about who's the owner of the file, any permission-related details. But you can also get extended metadata as well. There's two types of metadata that are indexed that are user-defined. One is S3 object metadata, which, if you're familiar with the S3 API, is metadata which is set at the time of object upload, which means it can't change unless you re-upload the object. But then there's also tags, which can be changed after the fact. And it can actually open up some interesting use cases where you can start to treat the file system and object store as though it were a database. And I'll show you a quick little demo on what that looks like in a moment. Now, the way that it's been implemented is effectively every so often, and it depends on how it's configured from a system standpoint. By default, it's at 15 minutes. You can dial it down all the way down to 15 seconds. We take a snapshot of the entire file system, and we take the changes since the most previous snapshot, and we come up with a delta that gets inserted into a table that is housed on our platform. From that point forward, you can run queries, you can run filters against that catalog to identify file names, you can identify sizes of files, that sort of thing. I'll show you a couple examples. And because it's snapshotted, it's a point in time consistent with a snapshot of the file system. So not only is the file system snapshotted, but the table itself is also snapshotted, which can open up some interesting use cases where people can go and do queries and they can understand how the file system has changed over a point in time. Now,
Andy, just quick question. If I upgrade from a previous version of Vast to 4.6, I automatically get this feature. and then it starts indexing on any new snapshot that I have, or is it going to go back in time and index old snaps?
It will actually go back and index the file system at the point in time that it was when you upgraded to 4.6. And then it will continue to snapshot going forward and keep track of any changes going forward from that point. And there are some configuration knobs you can turn in terms of how many snapshots you keep of the table, how many snapshots you keep of the file system, depending on the granularity and the history that you want.
Makes sense. Thanks.
Okay. Great. So let's talk about some ideas that you can use this for, right? So a lot of our customers find that when you have hundreds of millions or billions of files on a file system, it can be difficult to manage and understand where the capacity is going. And over the course of the last several releases, we've introduced new functionality to allow the ability for administrators to see how much data is contained within a folder or within a subdirectory tree. But now we've given the ability to basically come up with whatever ad hoc query someone might want. Some examples would be to show all files that are in a directory that are older than 90 days, perhaps for a lifecycle policy reason, or perhaps to ask users to clean up after themselves. You can also see things that have changed since a previous point in time. You can look at timestamp information in that way. And you can identify who the top users are, either by directory or by bucket or by project. And it's very easy for you to come up with queries as you go. And I'll give a couple example queries in a demo, but effectively imagine where if you want to go and find any file where a specific set of metadata was already tagged on that system. And so imagine you have a billion objects in an object store and you want to only find the ones that have a specific tag. This is the kind of catalog that will allow you to do that. And then you can also come up with complex predicates where you want to combine multiple filters into a single query. It can be done much in the same way where you would write a SQL query that has a compound filter. So I'm going to jump into a quick little demo just so you guys can kind of see what I'm talking about. And so first thing I'll do is I'll switch over to the Vast UI, make it a little bit larger in case it comes through small on your side. But basically, when you enable a catalog, there's a new tab that appears on the UI, and it allows you to enable it, and it allows you to set the granularity at which you want to be able to have those snapshots taken and how quickly you want the system to be able to catalog new information. And so there's a lot of flexibility here. I won't go through all the details. You can also identify which key value pairs you want separately indexed, but I'll save that for another time. Now, there is an interface from the user standpoint to be able to go in and, as an administrator, go and see things, right? So if I go to this catalog page, I can come up with a filter, right? You see that there's a whole list of columns that are available for me to choose from. I can come up with a set of Boolean logic filters to allow me to look for data based on what I care about. Now, in this case, I wanted to look for anything that was owned by me that had a type of PDF, right? And so within a few seconds, it comes back and I'm able to see the information about it. I can export this to a CSV file if I want to run a report against it or put it into Excel or something. But this is a really quick and dirty UI to be able to give you the ability to quickly see what's on the system. Now, what's the real power, though, is being able to come up with actual queries. And so I'll show you a few example queries. The first of which is to just describe what the table looks like, see what attributes are available to you. There's about 30 rows that are available, or I'm sorry, 30 columns. And if you notice, there's a couple down here at the bottom, user metadata and user tags. That's for key value pairs that can be stored within the metadata itself. So again, if you add metadata to an object, it will be indexed in this system. Now, let's take a quick little check and see how many files are on this file system. It's a relatively new cluster, so it doesn't have as many, but I can count the number of files in the system by just running a count against the table. And I end up, I think this is about 18 or 19 million files. That comes back pretty quickly. Now, what if we wanted to go in and take a look for, let's say, all the stuff that is in, that I own that's in the file system, right? So if I go and I do a quick query, I can run this and it generally comes back within seconds, right? I can see a list of 10 files that are owned by me. Again, that's across 19 million files. Now, what's more interesting is if we go in and look at the extended metadata that's available, right? So if I wanted to go and run a query where, for example, I want to look inside of this bucket or this directory, and I want to look for where there's specific user tags set, and I want to see what all the user metadata is based on what's been set at the object side. And so in this case, I run this query, it comes back very quickly, and we notice there's a series of key value pairs in the user metadata, which is again is this object metadata that can be uploaded using S3, as well as user tags, right? And so you can run filters based on what the tags are set to. So one example filter that you can run is, let's see where the user tag of process is set to true, right? So I go and I run that. And if I come back, I see that there's no rows available. So what we can do is we can go over to, in this case, I have an S3 browser open to this system, and I can pick one of these objects, and I can go and look at this object and say, you know what, I'm going to set this equal to true because I don't want it to be false. I set it to true, and then it's going to take a moment or two because I remember earlier we mentioned that the it runs every 15 seconds where we take a snapshot and update the catalog table. So it's not going to update immediately, right? So if I go back over to my command line and rerun my query, it's probably going to take a moment or two before it shows up. But the idea, again, is that you can set tags in the file system, you can set metadata on the file system, and then once you do that, it will begin to show up as, you can run queries against it. So now you can see that I actually, it updated automatically. I didn't have to do anything special. It's there. And so, you can imagine lots of different scenarios you could come up with. For example, if I wanted, like in this case, I have a whole bunch of photos where I've extracted the metadata from the photo to be able to index. And so you can do things like group bys. You can, in this case, I'm trying to figure out, okay, which models of phones were used to upload these photos, and I can run a query to do that very easily. And once you get used to the idea that you can treat your file system like a database, then you can come up with a lot of different ideas. So that's the demo, just to give you a quick little kind of snippet into what it looks like.
It's pretty awesome. So is there any like care and feeding in this database? Do we need to, like you say, we're backing this up automatically because it's getting snapped on its own. So it's kind of just free from an administrative point of view. It's pretty cool.
It is. You don't have to set anything up. It's basically enabled by default on new clusters. On upgraded clusters, it is something where you have to click a box to enable it, but it's in the UI. There's nothing special that you have to do to get it going.
Pretty cool. And eventually, maybe could this be like queried by external applications, like data protection applications that are trying to see like what files haven't been backed up? I mean, it seems like there's a lot of cool possibilities here.
Yes, and that's something we're working with several of the vendors on, which is basically to allow them to send us queries to compare a point-in-time snapshot with another point-in-time snapshot to build a list of changes, which can then be fed into a backup application or to an external indexing application that might want to store this index somewhere else.
Awesome. So someone just raised their hand. So how do we get that? Somebody's got a question here, I think.
Yeah. Hey,
You also have some questions if you want to take a look at them, Andy.
we got a few Q&A
Sure.
questions.
Yeah, I'll go through the catalog questions. There's a few here. So first one was, with the catalog introduced, will you be able to utilize this to detect ransomware attack on data, looking at the patterns, which seems like encryption is going on? That is a potential use case. We have not implemented in such a way that it's going to be useful for that immediately. But you can imagine that if you have a catalog of the file system and you know how to do differentials between 2 points in time, you can start to look for patterns. And so we're working on some ideas. We do have a project using AI and machine learning to look for anomalies. And this is one of those things that we will use for that. Let's see, there's another question, which is, sorry for this question, but this is my first fast office hours. There seems to be an appliance, or there seems to be an appliance that's great for on-prem, but is there a software version also built on x86 servers using Flash, et cetera? Thinking of deployment in the public cloud is another use case. Keith, actually, we'll get to that question a little bit later on because we have a new feature we're going to be announcing towards the end of this as well.
But perfect question. Awesome.
Yeah, and then Mark says, are access permissions adhered to in performing these queries? So the answer, there's two ways to answer that. The simple way is to say no. Administrators can see everything in the catalog. However, there is the ability to expose the catalog to other users and use a policy model to be able to identify which buckets and directories a user is able to query against. We have not yet implemented full granular access control checks within the catalog queries, because it is a relatively expensive operation to do an access check for every single file that you're trying to determine if someone has access or not. But it is something that we're looking into more deeply. And then the last one was, can you put tags on non-S3 objects? It's a great question. So VAST being a multi-protocol system, you can ingest a file using NFS or SMB. You can take that same file, and from the S3 API, you can apply a tag to it as though it were an object that had been uploaded using S3. It doesn't matter if it was uploaded using S3 originally. It can apply to existing files that came over other protocols.
So they just would create a view for the API, for the application they need. So they tag it, like say you've got like an artificial intelligence or machine learning application that's tagging those files, but now you need to present them over SMB or NFS. You could use the VAST catalog to find the files with the tags you want. That's a great question. That's really cool. Perfect.
And Mark asked, can I disable this feature completely? Interested from the security standpoint? Yes, you can click a box,
Yep.
disable it. You don't have to enable it if you don't want.
Demo lab. Do we have a demo lab for this today? So that's an interesting idea. So we've got like the SE labs and things. And again, kind of coming to the thing we're going to talk about at the end of the session with maybe the 4.7 VAST on Cloud feature, that would be another interesting area for somebody to play with this. So perfect. So performance, is there a performance strain on the system? Is there any overhead? We aren't walking
Great
the file
question. So you notice that there is the ability to decide what the granularity and frequency is in terms of how often you have that background task run. So any background task that has to operate does take some system resource. Generally, the impact is minimal. However, we've been a little bit conservative in the sense that the default value for how often the catalog will index is 10 to 15 minutes. It can be dialed down to a much lower granularity, or I'm sorry, a higher granularity if you think of it that way. But we want to make sure that people understand that there is going to be some amount of impact, and we try to minimize it wherever possible. Now, the good news is that generally speaking, the impact is in the CPU on the C nodes. So if you know anything about VAST, there's a separation between compute and storage. The good news is that if there were an impact for something like this, you could merely add more C nodes to the cluster without having to add more storage, and it would mitigate the impact.
Nice. Cool. Well, hey, the questions are great. Keep asking them. We're going to go and move on to the next subject. Phil is going to talk about multi-tenancy. So as we mentioned, a lot of service providers are using this, and in fact, other organizations are acting like service providers. So we've got this need to take all this scale and chop it up into nice segments. And Phil, do you want to jump in this? And again, this is another one of these features that's built on top of an existing component of the VAST architecture without a bolt-on. So it's really interesting.
Yep, exactly. So I want here to share on my screen. All right. So again, talking about multi-tenancy. So multi-tenancy is a feature that a lot of different storage providers have it out there. With that, multi-tenancy is something that becomes available upon an upgrade to 4.6. So if you have an existing VAST cluster, like a lot of the features, once you upgrade to the next version, you have these features immediately available to you. The interesting thing with multi-tenancy is that the design and the layout of the VAST element store always had somewhat of a multi-tenancy notion in mind with it, just by its design and the way that data is laid out within the element store itself. When it comes to upgrading to 4.6, we go through and we just pull back actually a layer to expose these multi-tenancies. And what I'm referring to is that internally there's a notion of a default tenant, which prior to 4.6, this is where all the element store live. This is where all the clients were able to go through and access the data from. With the upgrade to 4.6, we just pull back that layer. So not only do we have this default tenant with it, but we can go through and add an additional tenants. And this is the key, is that it didn't require any sort of real retrofitting to be done, or any kind of heroic efforts to go through and add multi-tenancy in there. It was already part of the product. If you don't want to go through and use multi-tenancy with 4.6, you don't have to. The flow and operations, outside of seeing some additional options when you create views and view policies and things like that, you don't have to go through and use it. It doesn't really change the flow if you're not interested in using it. All of this is all exposed in through our REST API as well. So it integrates very, very well with service providers that want to go through and dynamically create and remove tenants from their systems as they go through and add clients. We have the ability here to go through and add multiple identity providers. And when I refer to an identity provider, I'm referring to something like an SMB provider with Active Directory for SMB services, referring to LDAP as well, or for NIST. Currently with 4.6, we support up to 8 LDAP providers, a single NIST provider, and up to 8 Active Directory providers. With that, there's a limitation with 4.6 that we're only going to use one for SMB currently. That'll be lifted in a future release here. But we can go through and mix and match those providers within each one of the tenants as we see fit. There is per tenant encryption. So as you know, VAST has the ability to encrypt data at rest. That's something that's built into the product and has been built into the product from very early on. When it comes to multi-tenancy, we have the ability to specify individual encryption keys per tenant. For going through and be able to do that encryption on a per tenant basis, in addition to the existing isolation within the element store between the different tenants. In terms of network isolation, you've got a couple different ways you can go through and do it. Already, prior to 4.6, we had the isolation via C node pools and network ports. So we could go through and specify, okay, this group of C nodes or this group of network ports is going to be servicing out these IP addresses, and this other one's going to be servicing out a different set of IP addresses, and you could segment those physically, or you can go through and segment those via VIP pools and VLANs with that. But we also go through and add in with multi-tenancy this notion of a client IP address range, where we can actually go through and by using having multiple tenants share the same destination, same IP addresses, we can direct which clients have access to which tenants based on the client source IP address. With that, I'll show you a demo of that here in a moment. So how does this work here? So we have this VAST cluster. This kind of generally represents our VAST cluster here with everything there. We have our element store, which spans across multiple D nodes in the back end. And we want to go through and we're going to create some tenants. So we have a tenant called Alpha Industries with a home directory /home. Okay, we have a tenant called Beta Corp in here, which also has a home directory, and they're called /home as well. Now, these, even though they both have the same name, these are isolated within the tenant. They are unique within the element store with that, even though they have the same path name, but the path name is independent is unique to each tenant. It's not a global path name.
Phil, I'm just going to intersperse some questions as we're rolling here.
Sure.
How many tenants do we support in this current release? We've got a
so currently the default release is the default right now is 1,000 tenants. Okay. With that, there are some install time options that we can go through and set to go beyond that. But the default standard install is 1,000 tenants is how high we can scale with that.
Okay, great. Yeah, I'm going to try and weave some of these in, just kind of keep the flow going, because we're actually getting a lot of good questions here. So
sure.
Keep rolling and I'll jump in.
Yep. And I'll get to some of those other ones here in just a second. So let me get through this, and then we'll answer those questions afterwards. So within these here, we can go through. We can define our access based on a VIP pool. So we can set one VIP pool here for alpha.vast1.example.com with a range of IP addresses, and another one with a different range of IP addresses that's tied to one tenant or the other. And they're not sharing the same one. And these could be shared out via SMB, NFS, or S3. And then when a client comes in, the client access, determining whether they're going to access the home from Alpha Industries or the home from Beta Corp, is done based on which IP address or which VIP pool that client is going to be accessing. So nothing terribly unique about this. The interesting part is that when we start talking about a tenant address range defined by client IP range, we change things a little bit where we now have a common VIP pool here, that's shared on. This is shared by all tenants, and we define which range of client IP addresses we're going to go through and utilize, or we're going to go through and allow access. So Alpha Industries says, well, for 10.20.20.1 through 10.20.20.100, that will be allowed, those clients will be allowed to access Alpha Industries, but 10.30.30.1 through 100 will go to Beta Corp. So what happens is that when we have a client, client one comes in and that's got a source address in the 10.20.20.20 range, that will be accessing that IP address. There will be directed to Alpha Industries. A client coming in from a 30.30 range will be directed to Beta Corp. And a client coming in from another address that's outside of either one of those ranges, if it's trying to access that same VIP pool, will be denied access to that. So again, we can go through with the different tenants, be able to define, are we accessing things? We want to access things based on a VIP pool, meaning define on the VAST cluster side, saying, yep, I hit these IP addresses, I'm going to get this tenant, regardless of the client, or do I want to, go through and actually do some filtering? We can do combinations of both of these as needed there. So relatively straightforward there. Now, to go through and configure this within this, kind of just demonstrate how things work. I've got my VAST cluster here. I have defined within this, I've got a couple virtual IP address pools. For this one here, I'm just going to demonstrate this all tenant. So this one, basically, I'm using this address range here. This is associated with all of the tenants. And within that, utilizing some services that we have within VAST, the clients are going to come through and access it via this host name here. I have within my element store, I have two different home directories here. And one is assigned to Beta Corp, one is assigned to Alpha Industries. Within the tenants themselves, I can go through, I can define. So this one, I actually have three tenants. So I have my default tenant, which is the one that was existing. Then I have two different tenants here. And within these two different tenants, one of them is utilizing sli.vastdata.com for Active Directory, but has no external LDAP to get any other information from. So that's going to rely strictly on Active Directory for things like user resolution and POSIX attribute lookups, things like that. For the Beta Corp one, Beta Corp is utilizing just an LDAP provider for that. And we can go through, we can modify these. When I create a tenant, I can go through or edit a tenant. I can modify these providers as I see fit. If I had an NIS provider, I could add an NIS provider in here. I could add an LDAP provider. So really no different than as we had from existing setups.
So Phil, question about bringing your own keys, your own encryption keys, and I believe that's coming up here. So can encryption keys be managed? Actually, the question just moved on me. Can encryption keys be managed by the client, such as VAST does not have access to the keys?
So currently, the management plane that we have right now is a single management. So very much like the big catalog that we have, it's a single management plane for that. There could be via some REST API calls, some external manager to go through and restrict access, to the individual tenants. So right now, it's a single management plane. So the encryption keys, while they could be provided, will be applied to that tenant, but it is something that's going to be I guess we'd say visible to everyone. That is something that we are looking at a tenant-aware VMS, but currently it's just a single management plane for that. So, okay,
cool, thanks.
Yep. So how does this look? How does this look in play? Well, I've got here with my two clients here. Make this a little bit larger here. So I have two clients here. One client is defined as alpha client with an IP address range here. This one is defined with a different IP address. He's that. These IP ranges here will match. You see that this one has 5.83 as its IP. That's going to go to Alpha Corp. 5.87 goes to Beta Corp, like that. So really with this, I mean, the demo here is pretty simplistic for it. We're going to go through and just do a mount of this. We're going to mount this common IP address here on both of these. So when I mount both of these up here, when I'm going to see the same host name client, SE Lab, that same view. But when I go through and mount these, I'm going to go through and actually see different data here. I'm going to see different data indicating, and this is data that I pre-populated here, indicating different information for that. So even though externally they look like they're mounting the same thing, the client we're restricting based on the client. So, but that's kind of a once over with with multi-tenancy there, at least how to go through and set it up on that. And so we'll go through and take a look at some of the questions here and answer those.
There are two related questions about deduplication.
Yep.
It says, will multi-tenancy still leverage dedupe or data reduction between the tenants?
Yes.
So
does multi-tenancy still leverage dedupe within multiple tenants? So the question for there's two different parts for it. The answer is yes. The short answer is yes, it does, but it depends upon what the configuration is. So if you're using encryption, on this is where this may or may not happen. So for any tenant that has a common encryption key, so if you've got two different tenants that are using the same encryption key, or a tenant that's not using a separate encryption key from the main one that's being used for the default tenant or the default one on the system, then yes, those will dedupe. If it's a tenant that doesn't have that has a unique encryption key, then that will dedupe. The data reduction will only happen within that particular tenant. For that. When it comes to doing things like replication for that, same thing applies. It's going to depend upon how you have your replication defined, and what the replication looks like at the other end. So we do replication between tenants on a source and destination system, but you can replicate multiple tenants to a single destination that either does or doesn't have tenancy defined, but it would depend upon how that destination system is configured, whether it has a unique encryption key per tenant or whether it's the same encryption key across most of them.
Makes sense. Question about two tenants using the same IP space.
Two tenants in the same IP address space. So there is, we are working on that. There is some. There's not support in 4.6, and Rupert, correct me if I'm wrong here, but this would be the overlapping IP address ranges for that. I believe that is in there. Is that in there with 4.6, or are we bringing that in with 4.7 or later for overlapping client IP?
Currently not in 4.6. It'll be brought in with 4.7, which is our next release.
Yep.
Gotcha.
Okay.
Perfect.
And I think we've answered the first one on encryption keys. Client Vast Data doesn't have access to encryption keys. So yeah, that's on there. So there's not machine ID and network port level. So currently, no, it's strictly with just IP addresses there. That's not it's not based on network port or ID. So that is an interesting concept there for that. I sort of probably go through and take a look at that, but currently it's strictly based on IP.
Yeah.
In the
we're gonna
future, we will introduce VXLAN and VTEPs. So I think that kind of answers Matt's question.
Yep.
You can identify a particular VTEP for each one of your tenants, and then their traffic will automatically be encrypted and segregated at the fabric level. That is not a feature we have today in 4.6. It has been on the drawing board for a long time. So I think it's going to be released this year. And right now, I don't know if it's in 4.7 yet or not, or it might be early preview for certain customers on the VXLAN front end connectivity. I hope that answers your question, Matt. If it doesn't, please retype it in.
Yeah.
And I'll find
it.
And
again, we're going to have all these afterwards. So this is awesome, though. Thank you so much for everybody jumping in. I'm glad nobody's being shy. So this is exactly what we're hoping for. And this is a good segue into Rupert, right? So I think there was already a question about how do we ensure, we don't have a noisy neighbor problem. And that really goes right into our QoS policies.
Awesome. Are you going to present for me here, or do you want me to? Oh, there you go. Thank you. Thank you. Awesome. So let me introduce QoS policies. This is brand new at 4.6, and I'm really excited about it because it allows VAST customers to create different service levels on a single infrastructure. And that allows them to distribute the resources of the VAST cluster appropriately and make sure that actions of one tenant don't interrupt or disrupt or impact the other tenants. Now, the QoS policies, and I'm not sure I love the wording so much, is the new feature in 4.6, but we've always had server pooling. The server pooling feature that has been in VAST for a while now allows you to segregate the front-end servers, what we call C nodes, or also called protocol servers, for particular demanding workloads. Take, for example, an animation studio might segregate parts of the protocol servers for GPU farms, or in traditional HPC, you might have highly demanding scratch space on certain protocol servers and less demanding home directories on a fewer protocol servers. But that was at a hardware level. Now we can do it at a much more finer granularity by doing it with QoS policies. So what is a QoS policy? A QoS policy is just as it states. You can create a policy, and you can do thousands of policies, and multiple views or exports can consume a policy. So you could have one policy being consumed by all of your exports, or you could have 5 policies, or you can have 10 or 1,000. There's not a one-to-one relationship. Any view or export can consume any one of the policies, and the policies can be set both at a static level or a dynamic level, and can also be set on a consumption level or a provision level. And you can set the high watermark for bandwidth utilization and IOPS or IOPS on that view in that policy. I actually have a demo, a very short demo on the bandwidth side of it after these 2 slides, but it's kind of just the introduction to QoS policy. So much more fine granularity, and you can tune these on the fly. So while a view is being consumed by a client, you can actually, using the API or the command line or the GUI, change the policy. So you could say it's like, oh, I want to give this view more capabilities at night and less capabilities during the day when somebody else is using the system. And you can do that on the fly. Can I have the next slide, please? Now, on this slide, I kind of want to compare and contrast what I said earlier. QoS policies on the right-hand side is what we just introduced with 4.6. We've always had server pools. Now, what's the difference? Server pools is explicit. You're taking hardware and segregating it out into a pool and then assigning clients and views to that pool. QoS policies is on a view level, and you can actually mix the two. You can have QoS and server pools working together.
So when you say mix, do you mean there's a QoS policy inside a server pool, or just that you have both on the same? Okay.
You can have both on the same cluster, as well as you can have a QoS policy inside a server pool. So you can have your server pools and apply QoS policies in them, or you can have no server pools and apply QoS policies on the cluster. It's how you want to slice and dice it. It also provides a different approach from some of the questions around data security. Server pools allow you to segregate the data in flight and to keep the users or the workloads or the assets that are using those server pools separate from each other. QoS policies make sure that they don't impact each other, but QoS policies along with tenants will allow you to segregate your data across multiple tenants without having to segregate the hardware. So you can do it completely logically, and you can change it non-disruptively on the fly at any given time.
Nice.
Any questions around the QoS policies, which is kind of the logical fine granularity resource management perspective versus the less granular server-based resource contention management and the mixing of the two with regards to QoS?
So server pools are, I was going to say server pools are for larger, maybe more static, like mentioned HPC, and the QoS policies are more for, I'm a service provider and I want to do S3 as a service or NFS as a service for thousands. So yeah, I think that's awesome.
Correct. Yeah, and you can change your server pools on the fly too. It's just like you said, Steve. It's for the big workloads that you know are going to take up an entire front-end protocol server's capabilities. Right. Then just assign that front-end protocol server for the time that you want. Even with server pools, you can, through the API or the GUI, change it on the fly if you need to, and our system will accommodate that.
Perfect.
Okay, now I'm going to start sharing my screen here. Actually, I'm just going to share a couple of windows, so give me a second.
Yeah. And again, jump in with those questions. Super happy with the level of engagement we're getting today, so really appreciate it. And we'll talk more at the end maybe about how we can do this better. Maybe we dive into have finer grain, smaller sessions on more specific things. So, but yeah, let's keep rolling.
Can everybody see two screens? One is an iTerm screen and one's a GUI screen from the VAST GUI.
I see your GUI right now, and then I saw your terminal a second ago.
Okay, yeah, I'm on a
okay, there you go.
Okay. So I am going to kick off. I'll just show you. Right now, I'm on a lab system. So excuse me if something happens strange on a lab system. This is an active live lab system. Right now, there's no activity on it. I am going to kick off a workload on this system. And you'll see that this workload generates about 6 gigabytes of data. And you'll see here on my screen that this workload's consuming about 6 gigabytes of read data. And I'm like, oh my, they shouldn't be using 6 gigabytes of data. Let me change that. So I can actually go to the view. I can go down to this export right here. It's a tenant. And right here on this view, there's a QoS policy that you can pick. In this case, earlier in the first slide, I had high, medium, low. So high is about 1 gigabyte a second. So I'm going to select high. The system is going to make sure that everything is checked out. So you'll see this little box turn around for about 20 seconds. Everything's non-disruptive, won't impact the connections. And right now I'm on a hotel connection from Canada to the US. So everything's running a little bit slower, but in practice, things are much faster. And what
You didn't
happens
pay for the
once-
extra bandwidth?
I did, but
You did?
I
Okay.
don't know what that extra bandwidth
Get
does.
your
on that.
Marriott points there.
Yeah, exactly. And you know how it is with live demos, right? Like it was right before this demo, it was working quite quickly, and then suddenly, okay, update. I'm just going to click right through here, and it should update right away. And so I've just applied a high-level QoS policy. If you look at my screen right here, I was doing roughly 6 gigabytes or 5,800 megabytes. Now I've dropped down to 980. Now, when we say QoS, and when I set it for 1024 megabytes, it's going to be plus or minus 10%. It's a high watermark with a plus or minus 5%, plus or minus 10%, depending on what that number is. But it won't go much further from, even though I set it at 1024, you'll see that the QoS policy has limited bandwidth to right where it's asking for. And I'll go back to the dashboard, and you can see here that before we were doing 6 gigs, now it's dropped down to 1 gigs. And let's say, oh, that's still too much. I'm going to reduce it even further. And you can go anywhere you want. If anyone wants to speak up and change it to something else, we can. I can go here. I can change it to low. So let's say, okay, this view should also, it went faster this time. Should only get about 250 megabytes a second. And so I've applied it. You can see that it's practically instantaneous on the screen here. So about 250 megabytes a second, to plus or minus 10%. And if you go back to the dashboard takes about 10 seconds to update. Okay, it just updated. So you can see that this view on the fly, and you can do this via the RESTful API, you can do this via the command line, or you can do by the GUI. I'm doing it from the GUI because this is a visual zoom. So, and let's just say, oh, well, they called the CEO calls and says, what are you doing? I need this workload to go at full speed. You can go right back in and change it. And we do have customers who have completely automated this, like completely put up a control plane management to do this on the fly, completely with complete approvals, cycles, and there we go. And so
when you make a change like this, does it get recorded? So we're auditing admin actions. Does this get recorded that you change someone's policy from high to mid?
Yes, it does. We do have auditing on the actions, and then those audit records can be sent up to your auditing system of choice, and all of these actions are audited and logged. And now this workload is back at that full 6 gigs it was running at. So this is a very simple demo. We can do this with IOPS. We can mix it with IOPS and bandwidth. We can do it across multiple tenants. I have a video recorded where I have 6 tenants, and I'm changing it on the fly to show what the impact, that there's no impact on other tenants. They get what they are supposed to get based on the QoS policy that's been applied to their views.
Awesome. So we've got a few questions.
Any questions?
Yeah, there's some questions in the chat here, and there's actually
can you apply IOPS or QoS or just bandwidth? You can do both, or you can do IOPS only, bandwidth only, or IOPS and bandwidth. You can also apply it on a dynamic level. So let me show you real quick. If I'll take a little bit more time, Steve, if you don't mind.
Yeah, perfect. No, this is good.
I will.
So as long as we scheduled 45 minutes, but we're glad to go to the hour. So again, I think everybody's really embracing the questions here. So let's.
I stopped sharing my screen. So, but I won't take too much time to reshare it. Yes, you can. Perfect. And you can do it on a provisioned level or on depending on how much they've consumed. You can or by how much you've provisioned them, or just static on whatever they are. Can you set a QoS minimum? Today we do not have a QoS minimum. We will introduce a low watermark QoS in the future. Today it's just a high watermark. Is there an option to implement a QoS policy for a specific user? No. Today, QoS policies are on a per view level. I have seen this request come before. I would have to talk with engineering to see if there's anything on the roadmap on a per user level. Andy might know more, so if he does, he'll speak up on a per user QoS policy. You could have a CEO red alert or a command to just give them all the bandwidth they want before you even have to type. That is true. You can. We actually have that at one of our service providers, where they can actually just click a button because it's self-service on that service provider. So somebody could go in and say, I'm willing to pay for it, and press the button, and they get whatever bandwidth they want right off the bat. Can you over-provision the IOPS and bandwidth QoS numbers? Yes, you can. You absolutely can. And we guarantee no starvation as well, even when you over-provision. Can you see limits tied to capacity. Yes, you can have QoS limits tied to capacity. Like I said, you can type to capacity assigned, capacity consumed, or just overall capacity. When you talked about automating the settings of QoS, is the automation done in VAST control plane interface, or is the automation done through both? You can obviously do automation in on a command line, writing a script. You can obviously write a API to VAST. And the way I would do it in the GUI is set up a webhook so that something gets triggered, goes to your webhook, and then your webhook tells VAST what to do. We don't have an automation engine built into the GUI, if that's what you're asking. This IOPS throttling is interesting for database workloads. How does one get access to a VAST system or a hosted basis through a service provider? That you will hear about here in just a few more minutes. I think I've answered all the questions.
Yeah, and they're coming. So yeah, right now it says there's no open questions. So we'll go ahead and now segue into the next thing. So next we wanted to talk about a new feature. And Boone, go ahead and share the slide again, called Global Snapshot Clones. So this is kind of our first foray into some interesting things that are coming around the global namespace. I'm going to turn it over to Andy to talk about this one.
Sorry, I had to find that mute button. Actually, I'm going to go ahead and share my screen just to get the timing set up properly. So one, please. Okay. So, actually in our 4.6 release, we got a lot of features and sub features. But one of the ones we wanted to talk about more specifically was a sub feature known as Global Snapshots Clones. So basically, what it allows you to do is take a snapshot on any cluster and allow for that snapshot to be accessed as a read-write directory on another cluster. Now, these could be two clusters in the same data center. They could be clusters that are on the other side of the globe from each other. And the interesting thing is that there's a couple different options for how we can allow this to happen. The first of which is we basically take a snapshot, let's say on the New York cluster, and we aggressively replicate data to the Boston cluster. Now, what's interesting is that we don't need to wait until that replication is finished before the directory on the Boston cluster is read and writable, which means that I can take a snapshot and I can expose it as a global snapshot clone on the Boston cluster, and it's immediately read-write the moment I press the button, or within a few seconds of pressing the button to create that global snapshot clone. It's read-write accessible on the destination system. And when an IO request from a client, whether it be for metadata or for data or both, when it comes into the Boston cluster, if the data that we need in order to satisfy that IO request has not yet been shipped across the wire, we will effectively prioritize those blocks and metadata blocks for shipping so that the client does not know that the data wasn't there. So what does that really mean? It means that if, let's say, I go into a directory and I want to list the directory, if we don't have the metadata there yet for that directory, the client IO will take a little bit longer because we're having to fetch some blocks to be able to satisfy the IO request, but the client will never get an error. And from their standpoint, the system is fully read-writable. They can read, they can write, they can create files, they can delete files, they can do whatever they want. Now, keep in mind that this is based on a read-only snapshot on the New York cluster. What it means is that these changes are not being synced back to New York. That's not part of this flow. We do have a feature coming out later on this year, which will solve that problem as well. But today we do have the ability to take a read-only snapshot and allow for it to be read-writable in another location. Now, the interesting thing is that we can also do what's called a lazy clone. So the default is where we try and ship all the blocks as aggressively as possible. But there is another option, which is you can create a global clone where we don't ship any data until an IO request from the client comes in. And then, of course, as more IO requests come in on the client, we ship more data over to the target system. And so any data that a client is accessing over and over again will, of course, get the latency based on the system they're accessing, not based on having to fetch those blocks across the wire. But the intention in the case of a lazy clone is to effectively allow you to, let's say you have a, 100 terabyte directory in New York, and you want to do some processing against it in Boston or in another system. you can create a lazy clone, and basically there's just a checkbox whether it's eager or lazy. And when the data is shipped, it only ships over what's necessary for the client. It doesn't ship anything extra. So imagine you run a job that only needs to test something. It doesn't need to test everything. It doesn't need to read every file. So we don't need to waste any IO on that. And I mentioned earlier that this was kind of a package deal feature, right? So we got several different features that got cooked into the 4.6 release that are based on our snapshot technology, and global snapshot clones is one of them. I think that's all I got in terms of slides for this.
Yeah, it's a pretty simple one. So we don't have a demo. We do have a video of this demo we can dig into, but I think kind of the interesting thing that when we're talking to service providers, they like the idea that they can separate data availability from data protection. So maybe I want to, I automatically want to copy everything from New York to a low-cost data center, maybe in like Virginia, but I've got maybe a high-cost data center in London with animators or something I want to share a specific use case for. And it allows for kind of more application-driven, more user-driven replication. So I think that's interesting. And again, it kind of builds on other things. So there's one question: can you apply QoS on a global snapshot? And I know that's
oh yeah, I was answering that, but yeah, instead of me typing, I was going to answer that question. But so basically, there's a couple different contexts here. The first of which is that there are throttles you can place on how we replicate data, whether that be for global snapshots or for regular fast replication. So you can apply throttles in that fashion. We are extending it to be more QoS-like in a future release. So it's not just a throttle, it's actually a policy that you can set, but that's coming in a future release. And that impacts data not only that gets replicated across the wire, but also internally if you're doing a clone on the same system that you're on. So you can get a basic throttle today, and quality of service that's more fine grained in the way that Rupert previously showed is coming in a future release for that replicated traffic.
Perfect. All right, let's jump to the 4.7 preview real quick. And I definitely want to make sure we get, as engaged as this crowd has been, we want to ask a poll. We want to ask, like, if you like this kind of interactive thing, like, how can we do this again and do it better? So just real quick preview of what's coming in 4.7. We had a question about, will we be able to run VAST in the cloud? And yes, that's coming. So Andy, do you want to add any color around VAST on cloud, how that's going to look? Or
yeah, sure. So really quickly, we have extended ourselves to be able to allow for a VAST cluster to be run in the public cloud. Right now, it's in beta, and we'll be shipping betas to a bunch of customers over the next several weeks. But effectively, the initial launch will allow us to deploy a VAST system in Amazon EC2, where there will be a marketplace item. You can launch it. It will be a fully functional VAST cluster, albeit very small and potentially lower performing than one that's on-prem. There's a number of use cases that we're looking at using it for, one of which is to leverage that global snapshots feature that I mentioned earlier to be able to do cloud bursting use cases, but we'll let you stay tuned for that later on.
Perfect. We've got a group replication feature, which is similar to a star replication. As mentioned before, we're adding QoS ability to replication itself. We're seeing more and more customers who are putting virtualization workloads on us. So Hyper-V support's being added. A few other things here, and especially some focus on security, right? So we've got a lot of customers very security focused, and we're exposing that. External key management's another feature there. But I do want to jump to that poll real quick. So if everybody's still hanging on, one thing that makes me really happy, we got a lot of attendees and people are staying on today. So sometimes you get a webinar and people drop off, but we've got great engagement. So what we're going to ask is, what are we going to offer next, right? And if you don't see your topic here, just go ahead and put it in the chat. We would love to get more engagement like this. This is valuable for us. Hope it's a good use of your time. So we're seeing a lot of activity here. So boom, we'll leave this open. Any more questions, pop them in the chat. If we, essentially we're out of time, but we will certainly get back to you. This is great. We're actually getting a really kind of even distribution across all of our questions here. I don't know if Boone, we're going to end the poll because we're kind of out of time here. Who are the winners? Looks like data protection is probably going to be the winner, but is that popped up? Can everybody see that poll results? No. But yeah, so we data protection looks like it's ahead by 21%, but AI infrastructure is close behind. We've got some big announcements coming there. Storage trends and tool sets, 20% too. Yeah, so we talked about doing kind of a session where we go over kind of like, does the old way still apply? But hey, I want to thank everyone for coming on today. Thank you for your engagement. This has been fantastic. This will be, of course, recorded and available for you to watch later. And if you asked a question we didn't get to, we've got it in the chat. Thank you again. And please reach out to us, right? We are available. We should have shared our emails, but we're easy to get hold of. Reach out and we will get a hold of you. Thank you everyone for joining. Andy, enjoy beautiful Antigua. Rupert, have a great time in Toronto. Phil, you and I are at home, same with Boone, and everybody else at home. Have an awesome time. Thank you all for attending today. Really appreciate all the excellent questions.